Hello everyone, welcome to our channel. I am Muskan and I'm gonna help you with the subject chemistry. So let's start with general organic chemistry and IUPAC system. So let's start with types of carbon. There are three types of carbon: vinylic, allylic and benzylic. In case of vinylic, double bond carbon is present. Let's see some example. This is CH2 double bond CH2, so both the carbon in the double bond are vinylic. And when a chlorine is added by removing a hydrogen, so this becomes a vinyl chloride. So our next is allylic. In allylic is attached carbon next to the double bond carbon. So allylic is the carbon which is present next to the double bond. So this is a allylic carbon, and when a hydrogen is removed and Cl is added, this becomes allyl chloride. Now next is our, in case of benzylic carbon is attached to next to benzene. So this is a benzene ring and the carbon present next to it, this is benzylic. When we add chlorine to it, it becomes benzylic chloride. This is benzylic alcohol because alcoholic group is added to the benzylic group. So next is alpha, beta and gamma carbon. In this case, carbon with functional group is known as alpha. Next is beta and another next is gamma. So this is a functional group carboxylic acid COOH. So carbon to which the functional group is attached is known as alpha carbon. The next is beta and the next is gamma. Over here alcoholic group is present. So this is alpha and this is beta. Next we move on to acylic carbon. A carbon which is in CH3CO is known as acylic carbon and is represented as AC. Example CH3CO or AC. For example, next example is CH3COOH or ACOH, CH3COCl or ACCl. Now next is asymmetric carbon or chiral carbon. A carbon which is bonded with four different groups by a single bond is known as asymmetric carbon or chiral carbon. It gives optical isomerism. It is a carbon in which all the four different groups are, or the four attached groups are different. So now we are going to see the properties of different functional groups. Let's start with carboxylic acid. It is also known as alkanoic acid, alkane plus oic acid. So this is ethanoic acid, methanoic acid, and this is ethane dioic acid because two carboxylic group are present. Now some key points which you need to remember. Acid turns blue litmus red. Acid gives CO2 with bicarbonate. So bicarbonate plus acid gives, so bicarbonate reaction with acid gives a sodium salt and a carbonic acid. Carbonic acid is readily, so carbonic acid readily dissolves into H2O and CO2 and CO2 comes out. Next is cyclic acid. This is a dibasic cyclic acid. It can become as an MCQ in your exam. Acid react with alcohol to give ester in presence of mineral acid. OH of COH group and H plus of alcohol group is removed. So let's see an example. This is the acid and this is the alcohol. So OH from the acid one and H from the alcohol is removed and this ester is formed. Similarly, we see with mineral acid also we get an ester. These H plus are mineral acid and this alcohol, this acid, carboxylic acid can be a mineral acid also. So that will give an ester. So this is an open structure diagram. So we get an ester. Now if any acid gives OH and alcohol gives H plus in the reaction, then it is called ester formation. If any acid, it can be any mineral acid or carboxylic acid, if it is giving OH and alcohol is giving H plus, then it is called as ester formation. Now formic acid in vapor form is known as formalin. CH3COH on solidification is known as glacial acid. Vinegar, that is CH3COH, is 7%. In vinegar, acetic acid is 7% and rest of them is water. In case of carboxylic acid, it forms dimer due to hydrogen bonding. Now this carboxylic acid, where carboxylic acid is never present in the single form, it is always forming a dimer by hydrogen bonding. Peroxy acid is weaker as compared to carboxylic. Peroxy acid means it has a peroxy linkage. So when we deal with the acidic nature, we get to see that carboxylic acid is more acidic than peroxy acid. Now reason. In case of peroxy acid, intramolecular hydrogen bonding is present, so removal of H plus is not easy. Secondly, there is no resonance in peroxy anion. Now if we remove this double bond and make this carbon positive and this O negative, or when we remove this H plus and we get a plus sign over here, see, so this plus can do resonance. Now carboxylic acid reacts with carbene to give ester. So with carbene also it gives ester. So this is the carboxylic group. This is the carbene and this is the carbene which reacts to form ester. Beta keto acid or beta unsaturated acid on heating gives CO2, that is decarboxylation. Decarboxylation means removal of the hydrogen, carbon dioxide. Now this CH3, CH2, COOH. So this is the beta position. We see ketone group of the carboxylic acid. So when we heat it, the CO2 is removed and we get acetone. Now we see the reaction with soda lime. This is the acid and this is NaOH plus CO, which is known as soda lime. So this CO2 is removed and we get RH. Similarly over here, CO2 is removed and we get CH4. This is also CH4 and this is CH3D. Now why it is D and why this is H? Because the H comes from the NaOH portion, not from this portion. So that's why this is CH3D and this is CH4. In this reaction, lime is absorbed, the CO is absorbed by water. Now next we move to sulfonic acid. SO3H is known as alkane sulfonic acid. Now when CH3 is there, this is known as methane sulfonic acid. When CH2 is there, it is known as ethane sulfonic acid. Now some points. Acidic nature is this one has more acidic nature than carboxylic group. So now similarly we see the reaction with NaOH. First a salt is formed, again reaction we get an alcohol, and then we are seeing with the methane group we get the similar thing. Now this, instead of putting a salt we can put X and we get the X1. X can be any halogen. So let's start with ester now. This is the alkyl alkanoate. This is the open structure. Now let's see with the preparation. Preparation with any acid and alcohol. We see this ethyl methonate, methyl propionate. The small one is known as alkyl and the bigger one is known as O8. Now some super key points. Ester is neutral in nature with fruity smell. Now ester are formed from acid and alcohol in which OH group is acid and H from alcohol is removed, which we have seen earlier. Now next we move to amines. NH2 is known as amine, and when an alkane is added to it, it's known as alkanamine. This is ethanamine. Now there are primary, secondary, tertiary, all are functional isomers showing different properties. They all show different properties. The primary, secondary and tertiary are functional isomer. There are alcohol or halides are not functional isomers, but amines are functional isomers. So this is an exception which you need to remember. Now primary amine gives mustard oil test. Primary amines gives carbonamide test in which chloroform reacts with primary amine in which presence of KOH to give isocyanide, which is a foul smelling or bad smelling object. This is an amide which is reacting with NaNO2 plus HCl or HNO2. This gives an alcohol. Double bond is there. When double bond is there, this gives N2Cl, that is diazonium salt. So next is amide, RCONH2. This is amide group and this is the alkane part. So this total is known as alkanamide. Now this gives Hofmann bromide reaction, which is a famous reaction. This is an amide, KOH plus Br. This gives primary amines. When P2O5 dehydration is used, we get an cyanide. This is known as ethanamide because two carbon are present. That's why it's ethane. Next is alcohol. So ROH, that is alkanol. This is ethanol. This is propane 2-ol because OH is present in the second position. This ethane 1,2-diol. 100% ethyl alcohol is known as absolute alcohol. 95% alcohol plus water is known as spirit. If methyl alcohol is added in spirit, it is known as denatured spirit. 80% petrol and 20% ethyl alcohol is known as power alcohol. It is used as fuel in many bikes. Ethyl alcohol works on nervous system, causes unconsciousness, but methyl alcohol is poisonous in nature. It causes blindness if drunk. So these are the alcohol with different groups. Gives haloform test, that is iodoform, chloroform, bromoform test. This structure gives haloform test. So presence of this structure gives iodoform test. This R can be equals to H also. Next is ether, ROR, that is alkoxyalkane. Alkox is the smaller part and alkane is the bigger part. So this is the structure. This is the bigger part. So this is ethane and this is the smaller part. So methoxy. So methoxyethane. This is ethoxypropane, methoxymethane. Now these are some cyclic ether. So let's start with aldehyde and ketone. So this is the aldehyde group. There is a typing error. This should be H. So this is an alkenyl or RCOH and this is the ketone group or alkanol. Aldehyde start with one carbon but ketone start with three carbons. This is ethane diol because two aldehyde group is present. So some super key points which you need to remember. Ethers are explosive in nature due to peroxy formation. Aldehyde without alpha hydrogen shows Cannizzaro reaction. It is a redox reaction which takes presence of a base. So this is an aldehyde which doesn't have any alpha hydrogen and this is the base. So this is a salt formed and this is the alcohol formed. So this is the Cannizzaro reaction. Aldehyde gives Tollens and Fehling solution test except benzaldehyde. Benzaldehyde doesn't give Fehling solution test. Now next we come to aldol condensation. If aldehyde or ketone is having an alpha hydrogen, then it gives aldol condensation in presence of base or acid. So these are two types of aldehyde. When they react with acid or a base, they gives aldol condensation, means water is removed and we get an aldol. Aldehyde or ketone with the following groups gives haloform test. So this is the most important group which is required for the haloform test. Carbonyl compound gives crystal with NaHCO3, that is sodium bisulfite. So now let's come to cyanide and isocyanide. This is the nitrile and this is the isonitrile or carbolamine group. Isocyanide has very bad or irritating smell. This on reduction gives secondary amine and this on reduction gives primary amine. Now let's see their reaction with KCN and AgCN. KCN is attached as CN only but AgCN it's attached as isocyanide. Now with water this gives acid and this gives primary amine and methanoic acid. Now degree of unsaturation. This is the compound. Now we need to find the DU. So DU0 means all bonds are single. DU1 means one single bond and one cyclic group and one double bond and one cyclic group. Du2 means one double bond or two double bond or one double bond plus one cyclic or two cyclic. Now how to calculate du? So this is the formula 2n minus n1 plus 2 divided by 2, where n1 is number of carbon and n2 is number of hydrogen. Let's see some examples. So this is C5H12, that is pentane. So du is 2 into n1, that is 2 into 5, where n1 is 5 and n2 minus plus 2. So we get 0, so no double bond, only single bonds are present. So this can be the structures. Now C4H8. So we are getting it as 1. So one cyclic group is present or one double bond is present. So total structure is 5 and total isomer is 6. How come this is different? We'll get to know in the next chapter. If Du plus oxygen. So Du plus oxygen, then it is alcohol plus ether, and Du1 plus oxygen, then it is aldehyde or a ketone. So let's see, it's 0, that means it is alcohol or an ether. Du plus halogen. So replace halogen by hydrogen, and that is Br is triple equivalent to H. So we'll consider that as. So now we have done with the chapter, so let's do some questions. So first question says, which will give tolerance test? So this is our first option, which is an beta acid, beta ketone. This is an acetone, that is an ketone group, and this is an aldehyde. This structure on resonance will give an aldehyde. So A and C both are the answer. So D is the answer. This structure, the sulfonic acid is more acidic than CH3COH, that is carboxylic acid, due to resonating anion, hydrogen bonding, inductive effect, mesomeric effect. The answer is resonating anion. Now, which will give red PPT with ammonical Cu2Cl2? So, which will give? Obviously, option 1, one alkane, one alkyne will give. Iodoform test, we need to draw the open structure. So answer is all, because when we draw the structure so next we move to which will not give ester on heating. So this is the beta alcohol, this is alpha alcohol, this is gamma alcohol. So when we heat, which will not give, so all will not give, no one will give an ester. So our next question is, which is not acid after heating? These four are the acids. So when we heat it, one acid will form CO2, but still it is acid. This one has two groups, carboxylic. So after heating, when we heat it, this becomes CO2, and again, but still one is left. Over here also, if we heat, we get to remove CO2 and we get an acid. But over here, when CO2 is removed, we get aldehyde, so it is not an acid after heating. So next comes to this reaction, when NaNO2 plus HCl is reacted, we get N2Cl, or when this is an phenol, means whole amine group is removed in this option, in these two options. So this is not possible. When we have seen it above, that when this reacts, N2 is formed. So either this or this. But this is not possible because N2 reacts with only with the nitrogen which is attached to the benzene, not with the benzylic carbon. So this is the answer. Next we come to, so next we move to which is having maximum boiling point. This is an acid, this is a primary amine, this is an aldehyde, this is an alcohol. So we have seen in the above that acid has the maximum boiling point. Next is CaC2 plus water. This is the product. When aluminium react, we get methane. This is the KH. And so for this is a dehydrating agent, so water is removed from here. So we get. So let's start with some common tribal name which you need to remember for the example. If the CH3 is present in the second carbon, then it is iso, and 5 carbon are there, so isopentane. On over here, second carbon, the structure is present, so this is isooctane. And if it is tertiary structure, then it is neopentane. This is tryptane. This is active amyl group because this group is active. Now come common alkene. This is alpha butylene, beta alpha because first carbon is involved, beta because second carbon is. This is isobutylene because second carbon has a methyl group, and butylene means a double bond. This is isoprene. This is allene. Now some alkyne. This is purified acetylene or nitroline. This is vinyl acetylene. This is allyline. Some arenes, this is benzene, this is naphthalene, this is anthracene, this is phenylethrine, this is styrene, this is orthooxylene, this is mesethylene, this is acetophenol, benzophenol, this is TNT, this is picric acid, this is Hessenberg reagent, this is tessile, this double bond, and this structure. Because water is removed from the. So this is the Hinsberg reagent. This is tosyl fluoride. This is orthocresol. This is catechol. This is quinol or hydroquinone. Other cyclic group. This is furan because these are the compound which are having oxygen or nitrogen or sulfur within it. This is pyridine. This is quinylene. This is thiophene, pyrrole, oxyran, indol, condol, imidazole, azulene. Now this is a very important compound because people get confused in it. This is BHC benzene hexachloride. That is 6,6-indane, lindane or gamex. These are the common name, and this is the IUPAC name benzene hexachloride. And this is hexachlorobenzene. Now some acid tribal names. This is valeric acid. This is isovaleric acid. This is active valeric acid. This is acetic acid. This is formic acid. This is toluic acid, salicylic acid, alpha phenyl lactic acid, sematic acid, anthranylic acid. That's all for today. So tomorrow we'll start with isomerism. Thank you everyone. So this is the Hinsberg reagent. This is tosyl fluoride. This is orthocresol. This is catechol. This is quinol or hydroquinone. Other cyclic group. This is furan because these are the compound which are having oxygen or nitrogen or sulfur within it. This is pyridine. This is quinylene. This is thiophene, pyrrole, oxyran, indol, condol, imidazole, azulene. Now this is a very important compound because people get confused in it. This is BHC benzene hexachloride. That is 6,6-indane, lindane or gamex. These are the common name, and this is the IUPAC name benzene hexachloride. And this is hexachlorobenzene. Now some acid tribal names. This is valeric acid. This is isovaleric acid. This is active valeric acid. This is acetic acid. This is formic acid. This is toluic acid, salicylic acid, alpha phenyl lactic acid, sematic acid, anthranilic acid. That's all for today. So tomorrow we'll start with isomerism. Thank you everyone.